So we have a problem statement here. If this set is represented by this uppercase letter U, and here it is mentioned that X, so X is the element such that it follows this particular property, that is x power 5 minus 6x to the power 4 plus 11 times x cube minus 6x square, that is equal to 0. So we need to resolve this particular equation to get the values for U, and the same holds for A. So set A represents X, and this will satisfy this X must satisfy this particular equation, that is x square minus 5x plus 6, that is equal to 0. So since it is a quadratic equation, so we'll be getting here two distinct values, and here set B is represented by x such that x square minus 3x plus 2 equal to 0, and here this U is mentioned here that this is the universal set. So if this is the universal set, then what will be the number of elements present in A intersection B whole complement? So that is what the problem statement is asking for, right? So now what we can do is that first of all we need to resolve this particular equation. So for this, first of all we can factor out x square out of this, and after that we can write here x cube minus 6x square plus 11x minus 6, that is equal to 0. Now here we can write this one as x square, and this internal expression can be written as x minus 1 minus 5x times x minus 1, and here plus 6 times x minus 1. So basic algebraic manipulation. Now from this we can write this x minus 1 as the common factor, and the quadratic equation over here, that is x square minus 5x plus 6, that is equal to 0. And from this we can just factor out this quadratic. So if you can observe here, this is nothing but x square minus 2x, this minus 5x can be written as minus 2x and then minus 3x. So from that we can write this one as x minus 2 times x minus 3. So from this cubic equation we are getting three distinct values. So from this we can clearly say that x will belong to this particular set, that is 1, 2 and 3. So this represents my universal set. So my universal set contains the element 1, 2, 3. In the similar way we need to solve the equation for this particular A as well, and this is something we have already solved. So this can be written as x square minus 5x plus 6 is something that we have already factored out. So I'll just take this part and substitute over here. So when I resolve this, so for this particular expression I'll get that x will belong to this element, that is 2 and 3. So this represents the set A, and in the similar way we can resolve this particular set B as well. So I'll just copy this and I'll mention the set B over here, and here we can say easily that my set B, since it is a quadratic equation, on solving this quadratic equation we will get 1 and 2. Now so we have this universal set 1, 2, 3, and the set A, that is 2 and 3, and set B we are having here 1, 2, right? Now the number of elements present in A intersection B whole complement, so this can be written as the number of elements present in case of universal set minus this particular set which is mentioned over here, right? And that is nothing but this will be 3, and hence for this particular problem statement the number of elements present in A intersection B whole complement, that is going to be 3. So here 3 is the answer.